Unit 3, Part 1, Computer Programming Essentials. These slides are designed to provide some focus on areas from the book that are essential for mastering the course objectives. So you can use these as a guide when you are reading the textbook to make sure that you are hitting all the high notes and covering what needs to be covered. In this chapter, we will learn about declaring and using constants and variables. We will use an integer data type, the Boolean data type, a floating point data type, and the JOption class to accept GUI input, that's graphical user interface input from the user. We are going to perform arithmetic and understand about type conversion. First, let's recap from Chapter 1. A constant is something that doesn't change. And in our first program in Chapter 1, we saw that first Java program was in double quotes, meaning that it was a string constant or a literal constant to be taken literally with each use. So each time we ran that program, first Java program was displayed in the output window. Similarly, we could have a numeric constant, which is a number. Say the number 5 is a numeric constant. It will always be 5 every time it's used. We can also have a variable, which is a named location in memory. And we use a variable to store a value that we need for the running of our program. A variable can only store one value at a time, and its value can change, the value that it's holding can change over the life of the program. For example, if we wanted to calculate the average age of students in this class, we could create a variable and store each student's name in a variable as we add them all together. When we are declaring variables in Java, Java is what is known as a strongly typed language. That means we have to specify what the data type is of each variable. We can't just say, we're going to store something here and we'll figure out what it is later. We have to determine what its data type is. And the data type dictates what we can do with the value that's stored there, how much space will be allotted for the value that's going to be stored there, and so on. There are basically two different types in Java. One is a primitive type, and that's the type we're going to really be focused on in this chapter and for the next few chapters. And the second is a reference type, which is more complex, and we'll get to that later. But primitive types are all keywords. They're all built into Java. Here's a summary of the primitive data types. We are only going to be using 4 of these. So we will use int, we will use double, char, and Boolean. The others are all variations on this theme, like a short is a type of integer, but it takes up less memory. We will be using int, double, char, and Boolean. Those are the only ones you need to worry about for this class. To declare a variable, we have to provide it with a name. And the names for variables follow the rules for identifiers that we learned about in the first chapter. It must start with a letter. In the case of variables, we always start with a lowercase letter. It must not include any spaces or special characters, and it must not be a keyword. So in our variable declaration, the variable declaration is where we say, yo, Java, we need to create a variable. We have to specify the data type of the variable and the identifier, or the name for the variable, and then a semicolon at the end. If we want to, we can also give it an initial value, and you'll see an example of those in just a second. When we are providing an initial value, we use the assignment operator. The assignment operator is the equal sign, and the equal sign says in Java, it says take the stuff that's on the right, whatever it may be. We call that the R value, R for right, the stuff on the right-hand side of the assignment operator, the R value. Take the R value and put it in the location, the variable specified on the left. That's the L value because it's on the left. So we take the R value and put it in the location that's specified by the L value. That's what the assignment operator says. So even though in math, you may use the equal sign to test for equivalence to see if two numbers are equal, like x equals 5. It's going to be true or false. X is either equal to 5 or it's not. We don't do it that way in Java. In Java, the equal sign is the assignment operator. Initialization is the term we use when we are providing a variable with an initial value. So when you make an assignment, when declaring the variable, we say that we initialized that variable. And assignment is when you give a variable some value. So typically we say that the initial value is the initialization, and assignment happens after initialization. So any subsequent change we make to that variable, we call an assignment. And associativity is the $5 word that basically means the order of operations. An order of operations in Java is very similar to what you learned about already in math, probably in 3rd grade or so. Remember, please excuse my dear Aunt Sally. We do parentheses first, then multiplication and division, and then addition and subtraction. Notice I left out exponents. We handle that differently in Java. So here's an example of declaring variables in which we supply an initial value. Int my age equals 25. The data type is int, the variable name is my age, and the initial value is 25. Int your age equals 19. Int is the data type, your age is the name of the variable, and 19 is the initial value. When declaring variables of different types, you must use a separate statement for each type, so you have to put them on their own line. When we are creating named constants in Java, we can do the same thing as we would with a variable, except we use the keyword final. We put the word final to the left of the data type. And the reason we might want to create a named constant is for something that doesn't change. For example, if we are writing a program to calculate how much sales tax someone would pay, we would include a named constant for that sales tax rather than just putting the value that the sales tax is. Like in Arizona, in Phoenix, I think it's 8.9%. So rather than putting 0.089 somewhere in our code, we actually create a named constant for it, call it tax rate. The reason for this is because we want to avoid what's known as magic numbers. Numbers that we really, why are we using 0.089 in our code there? What value is that? It makes our code more descriptive to use named constants. So we'll see an example of that in this week's programming assignment. So to recap, reasons for using named constants: to make your programs easier to read and understand, to enable you to change a value at one location. What if the sales tax changes? What if the tax rate goes down? We want to change it so that we're charging people the right amount of tax. To reduce typographical errors. If you've got magic numbers, it's easy to make a typo. If you type 0.89 in one place and 0.889 in another, it's tough to catch that kind of error. And we want them to stand out separate from variables. When we're naming constants, we name them in all caps. It's kind of like we're shouting, but we use all caps just as a way to indicate to the programmer, hey, this is a constant and not a variable.